Hey, have you ever looked up at the moon and thought, what if we could live there? Not just visit, but actually build a base, settle down, and make it a second home. Well, that's exactly what we're talking about today. By 2040, we might see the first permanent human presence on the moon. And this isn't just a dream, it's quickly becoming a reality. But how do we get there? How do we go from a barren, lifeless rock in the sky to a thriving lunar base where humans can live, work, and even explore beyond? Now, we've been dreaming about living on the moon for decades. The Apollo missions were the first big leap in this direction. Remember those iconic images of astronauts planting the flag, hopping around in their bulky suits? That was 50 years ago, and since then, we've taken a bit of a step back from the moon. Sure, we've sent probes, rovers, and even some high-tech telescopes, but humans? We haven't set foot on the moon since 1972. But all that's changing now. In fact, we're already on the path to building that base. NASA's Artemis program is planning to put the next astronauts on the lunar surface within the next few years, and private companies like SpaceX are gearing up to send their own missions. There's a real buzz right now about space, and the moon is no longer the impossible frontier it once seemed to be. So, what's the plan for the next 2 decades? How do we actually make a sustainable working base on the moon? What technologies will we need, and who will be the ones building it? In this video, we'll explore all of that, step by step. We're going to dive into the latest technologies, what life will be like for the astronauts on the moon, and the global effort it's going to take to make this happen. But before we get into all that, let's take a step back and ask, why the moon? Why is it so important for us to have a base there? What makes it such a good spot for humanity to start expanding beyond Earth? Well, the moon isn't just a place for cool photos, it's a stepping stone to the rest of the solar system, and who knows, maybe even to distant stars someday. But let's get into that, because understanding why we're building a base on the moon is where all this really begins. So let's start with the big question. Why the moon? Why not just skip it and go straight to Mars? After all, Mars is the big target, right? Well, here's the thing. While Mars might be the ultimate destination for many of us, the moon is much more than just a stepping stone. It's got a lot of things that make it a perfect starting point for humanity's space ambitions. First off, the moon is close. It's just 240,000 miles away, compared to Mars, which is millions of miles from Earth. That proximity means that building a base there could give us the chance to test out all sorts of technologies that we'll need for deep space exploration, like life support systems, energy production, and how to survive in a harsh environment for long periods of time. If something goes wrong on the moon, it's not as big a deal as if something goes wrong on Mars. We can get supplies or fix things much faster, so it's a perfect training ground for future missions. And then there's the moon's resources. You might have heard about something called in situ resource utilization, or ISRU. It sounds complicated, but it's really about using what's already there. The moon has ice, especially at its poles, which could be turned into water. And if you have water, you've got the basics for survival. Drinking water, oxygen, and even fuel for rockets. The moon also has materials like regolith, a kind of lunar soil, which could be used to build structures. Instead of hauling everything from Earth, we could literally build what we need using resources right on the moon itself. That's a game changer. But let's not forget the scientific benefits. The moon is like a time capsule from the early days of the solar system. It hasn't changed much in billions of years. By studying the moon's surface, we can learn more about Earth's history, and even the history of the entire solar system. Imagine what we could discover about the formation of planets, the solar system's evolution, and even the origin of life itself. Plus, the moon's surface is a great place for astronomical observations. Its lack of atmosphere means there's almost no light pollution, so it could be the perfect place for space telescopes that give us a clearer view of the universe. Now let's talk about why 2040, why this specific time frame, why not 2050 or 2060? The short answer is technology. Over the past few years, we've made huge strides in space technology. We've got reusable rockets like SpaceX's Falcon 9 and the upcoming Starship, which drastically reduce the cost of space travel. NASA's Artemis program is getting ready to send astronauts back to the moon, and private companies are pushing hard to develop lunar landers and habitats. All these innovations mean that building a base on the moon is not just possible, but within reach. And then there's the money and global interest. The 2020s saw a resurgence in space exploration, with countries like China, India, and Russia ramping up their lunar programs. There's also growing commercial interest. Private companies aren't just launching rockets, they're planning on getting involved in mining, building infrastructure, and even running hotels on the moon. This combination of government agencies and private companies all working together means we're more likely to see a real, functioning base by 2040 than ever before. So, it's not just about dreaming big anymore. The moon is becoming a realistic goal, but don't think this is just about setting up camp and calling it a day. There are huge challenges ahead. Making the moon a second home for humanity will take a lot more than just sending astronauts there for a visit. We're going to need to figure out how to make it sustainable long-term, how to live and work there, and how to survive in one of the harshest environments we can imagine. And that's where the real adventure begins. Alright, so we've talked about why the moon is so important. But now let's get into the nitty-gritty of how we're actually going to make a lunar base happen. It's not just about dreaming up cool ideas, it's about building something that can survive on the moon, something that will last. And that means we need some serious tech. Let's start with how we're actually getting to the moon. Right now, the plan is for missions to be launched using rockets like NASA's Space Launch System, or SLS, and SpaceX's Starship. Both are designed to carry heavy payloads to the moon, which is crucial when we're talking about sending all the equipment needed to establish a base. And these rockets aren't just one-time use, especially with SpaceX's Starship, which is designed to be reusable. That's huge because reusable rockets drastically cut the cost of space travel. And trust me, when you're talking about building something as massive as a lunar base, cost matters. Once we get there, we'll need to land, and that's where the next piece of the puzzle comes in. Lunar landers. These are specially designed vehicles that can transport astronauts and cargo to the surface. Unlike the old Apollo landers, these new landers will need to carry a lot more. Think habitat modules, tools, food supplies, water, and everything else we'll need to set up camp. NASA, along with companies like SpaceX, Blue Origin, and even others, are already working on this. For example, SpaceX is developing a version of Starship that could land on the moon and return to Earth, which is pretty mind-blowing when you think about it. But landing is just step one. The real challenge starts once we're on the lunar surface. Let's talk about the habitats, the places where astronauts will live. The first thing that comes to mind is how to build structures that can withstand the extreme conditions on the moon. The temperature swing is insane. During the day, the surface can get up to 250 degrees Fahrenheit, and at night it can drop to minus 250 degrees. That's an extreme environment by any standard, and we have to build habitats that can protect against both the heat and the cold. One of the options that's been talked about is inflatable habitats. These could be lightweight and compact while providing enough space for living and working. Once they land, they would inflate and provide a protective shell for astronauts, but there's also the idea of building habitats directly into the moon's surface. It turns out the moon's regolith, or soil, can actually be used to create strong, protective layers. Imagine using a giant three-dimensional printer to build the structure using lunar material itself. Not only would this cut down on the cost of shipping materials from Earth, but it also provides better protection from radiation and micrometeorite impacts, which are a huge concern on the moon. And let's not forget about power. How are we going to keep the lights on up there? The moon doesn't have an atmosphere, which means there's no protection from the sun's rays. So solar power is a key player here. We'll need large solar arrays to collect energy during the moon's 2-week-long day. But when night falls, it's another story. The lack of sunlight means that we'll need reliable storage systems, things like batteries or maybe even nuclear power for backup. The good news is that we've already got a lot of experience with solar panels, and batteries are getting better every year. Plus, nuclear power has been getting a lot of attention lately as a way to provide steady, reliable energy in remote locations. But it's not just about power and shelter. There's also the issue of getting around. The moon's gravity is only 1/6 of Earth's, so that's great for jumping around but not so great for getting things done. We're going to need lunar rovers, vehicles that can navigate the surface, carry supplies, and help astronauts explore. These rovers will be key for both building the base and doing scientific research. And because the moon has no atmosphere, that means no weather to slow us down. The only thing astronauts will have to worry about is the terrain itself and the lunar dust, which is surprisingly difficult to work with. That stuff gets everywhere, and it's incredibly abrasive. So, rovers will need to be tough, and astronauts will need to be extra careful with their equipment. And then, there's communication. Think about how important it is for astronauts to stay in contact with Earth. There's no cell service on the moon and no Wi-Fi hotspots. We'll rely on communication satellites to send data back and forth. These satellites will help keep the base connected to mission control back on Earth, and they'll be crucial for coordinating future missions, especially when it comes to deep space exploration. So, now we know what kind of technology we'll need to build a base on the moon, but the real question is, how do we even get started? After all, we're not just going to land a bunch of equipment and hope it works. Getting to the moon and building a base there is a huge undertaking, and it's going to take years of preparation before we can send humans back. One of the first things we'll need to do is send robots and unmanned spacecraft to the moon to scout out the best locations for a base. NASA's Artemis program is planning to send a series of uncrewed missions before any astronauts land. These missions will help map out the surface, test new technologies, and gather information about the moon's resources. We'll need to know exactly where the water ice is, where we can mine lunar regolith, and which areas are best for setting up solar power stations. Now, it's not just about sending a few satellites or rovers. We'll also need to build infrastructure on the moon before humans arrive. This is where robotic construction comes in. Think about it. We're not going to have a fleet of astronauts sitting around waiting for the first base to be built. Instead, robots will do a lot of the heavy lifting. In fact, we've already seen some early versions of robotic construction in space, like NASA's Viper rover, which will be used to explore the lunar poles in search of water. These robots will also help prepare the landing sites, set up habitats, and start building the first power stations. They'll essentially lay the groundwork for the humans who come later. Before the astronauts even set foot on the moon, we'll also need to test out all the equipment. That means sending prototypes of everything: lunar habitats, rovers, tools, and even spacesuits. These tests will likely take place in harsh environments on Earth first, like Antarctica or the Mojave Desert. We'll replicate the conditions astronauts will face on the moon: extreme cold, dry air, and long stretches without sunlight, to make sure the gear works before it leaves Earth. And then, there's the testing of the rockets and spacecraft. NASA's Space Launch System, SLS, and SpaceX's Starship have been under development for years now, but they still need to be tested under real mission conditions. SLS is going to be the rocket that will carry astronauts back to the moon, but before that happens, there will be a series of uncrewed missions that test the systems and ensure they're ready for humans. And with Starship, SpaceX is planning on conducting orbital and lunar missions to make sure their massive vehicle is capable of safely landing on the moon and taking off again. One of the most exciting parts of this preparation phase is the first mission that will bring humans back to the moon. Artemis 1, an uncrewed test flight, is already scheduled to launch in the next few years. This mission will send NASA's Orion spacecraft around the moon, testing the rocket and the systems that will eventually carry astronauts. Following that, Artemis 2 will be the first crewed mission in the Artemis program, sending astronauts on a journey around the moon and back to Earth. It's all building toward Artemis 3, which will finally land astronauts on the moon once again, this time near the lunar South Pole. But we're not just sending astronauts up there for a quick visit. The goal is to establish a long-term presence. Once the Artemis missions begin, they'll gradually increase in complexity, with more and more astronauts spending time on the moon. The first missions will focus on testing out basic operations like setting up habitats, collecting resources, and building infrastructure. But as the years go by, these missions will get more ambitious. Eventually, we'll need to have permanent infrastructure. This could mean everything from large research labs to greenhouses for growing food. These tests will help us understand the medical needs of astronauts and what kind of technologies will be required to keep them healthy. Beyond health, there's also the question of social dynamics. It's one thing to send astronauts to the International Space Station for a few months, where they can communicate with family and friends on Earth, but when you're living on the moon for extended periods, you're going to need to consider the psychological impact. Astronauts will be isolated with limited social interaction and the vast emptiness of space around them. The isolation could be tough on their mental health, so understanding how to support their well-being will be a huge part of the preparation. Alright, so we've covered some of the big picture ideas: why the moon, what technology we'll need, and how we're going to prepare. But now, let's talk about the real challenges. Living on the moon isn't like taking a weekend trip to a remote cabin. It's a whole different ballgame. The environment is unforgiving, and humans just aren't built for it. So, how do we make sure astronauts can survive and thrive up there? First off, let's talk about the moon's atmosphere, or rather, its lack of one. The moon doesn't have an atmosphere like Earth. That means no breathable air, no weather, and no protection from the sun's radiation. On Earth, we're protected by our thick atmosphere, which absorbs harmful radiation and shields us from meteors. On the moon, it's the complete opposite. Astronauts will be exposed to higher levels of solar radiation, and without that atmospheric cushion, small micrometeorites are constantly raining down on the surface. Even tiny particles traveling at high speeds can do some serious damage. This is one of the main reasons why building a base that can shield astronauts from these threats is so critical. To handle radiation, we'll have to make sure that lunar habitats are as well protected as possible. One of the ideas is to use the lunar regolith, the soil on the moon's surface. It's a bit of a workhorse because it's not just dirt. It could be used for construction, but also for radiation protection. The idea is to cover habitats with a thick layer of regolith, using it as a kind of shield. Some researchers are even thinking about using three-dimensional printing technology to create solid walls out of this material. The more we can use what's already on the moon, the less we have to bring from Earth, and the more sustainable the whole operation becomes. But radiation isn't the only environmental threat. The moon has extreme temperatures. One side of the moon during its 14-day day gets scorching hot, up to 250 degrees Fahrenheit, or 120 degrees Celsius, while the other side, during the 14-day night, drops to a chilling minus 250 degrees Fahrenheit, or minus 157 degrees Celsius. So, how do you live in a place with such drastic temperature swings? Well, part of the solution lies in the insulation and materials we use to build habitats. You'll need materials that can withstand both extremes, keeping the inside of your base comfortable, no matter what the outside temperature is doing. But it's not just the buildings we need to worry about. Spacesuits, tools, equipment, and even food storage have to be designed to handle this temperature roller coaster. Next up is the moon's gravity. It's only about 1/6 of Earth's gravity, which sounds fun at first. Who wouldn't love to bounce around like an astronaut in the movies? But that low gravity actually causes some real problems for humans over long periods. It's been shown that in low-gravity environments, astronauts start to lose muscle mass and bone density. On the ISS, astronauts have to exercise for hours every day just to maintain their physical health, and the same will be true on the moon. Long-term exposure to low gravity could cause permanent health problems if we don't find ways to combat it. And it's not just muscle and bones. The lack of gravity also affects how fluids move in the body, which can cause issues with things like blood circulation and the way we digest food. There's still a lot we don't know about how humans will adapt to living on the moon for extended periods, and that's why scientists will be closely monitoring the health of astronauts who live there for long durations. It's going to take a lot of research to figure out how to prevent the physical toll of low gravity and keep astronauts in peak condition. Then, there's lunar dust. If you've ever been to a desert, you know that dust can get everywhere. On the moon, it's even worse. Lunar dust is fine, sharp, and incredibly clingy. It sticks to everything: spacesuits, tools, equipment, and even the astronauts themselves. It can be a huge problem because that dust is not only abrasive, but potentially toxic. It could damage equipment or cause respiratory issues if astronauts inhale it. NASA and other space agencies have been studying ways to prevent it from spreading, like using airlocks to clean off spacesuits and equipment before they go inside the habitat. But lunar dust isn't something that's easy to deal with. It's going to require constant vigilance and special technology to keep it from becoming a bigger problem. Another challenge is the isolation. Living on the moon means being far away from home, cut off from family, friends, and everything familiar. It's a completely different kind of isolation than what astronauts experience on the International Space Station, where communication with Earth is just a few minutes away. On the moon, though, you're dealing with the harshest conditions in the solar system, with limited social interaction, no fresh air, and no green trees to look at. The mental health of astronauts will be just as important as their physical health, if not more so. How will they cope with the loneliness? How do you stay sane when you're months away from Earth with no real way to escape? Astronauts will need to stay occupied and have access to entertainment, communication with loved ones, and regular psychological support. NASA has already been looking into this for long-duration missions, with some ideas like virtual reality, video calls with family, and even creating a comfortable, homey space inside the habitat. The good news is that we've learned a lot from the ISS and other space missions about how to keep astronauts mentally healthy. But the moon will be a whole different ballgame and the stakes will be much higher. Okay, so we've covered a lot of the technical challenges of living on the moon, but one thing we haven't touched on yet is how we're actually going to build all of this. And the answer to that? It's not just going to be NASA or a few government agencies. This is going to be an international effort, with a mix of both public and private companies working together to make it happen. Think of it as a massive global team effort, with everyone bringing their strengths to the table. First off, let's talk about the international angle. The last time humans went to the moon, it was a race between the United States and the Soviet Union. It was a symbol of Cold War rivalry and national pride. But today, it's a totally different story. Countries around the world are not just interested in going to the moon, they're actually teaming up to make it a reality. In fact, NASA's Artemis program is already designed to be an international collaboration. The United States is working with countries like Canada, Japan, and the European Union, and they've all committed to sharing technology, resources, and expertise to build a sustainable human presence on the moon. Take the Lunar Gateway, for example. This is a planned space station that will orbit the moon, acting as a staging point for missions to the lunar surface. The gateway will be built in collaboration with international partners, with contributions from the European Space Agency, Japan's JAXA, and Canada's CSA. The idea is to have a platform where astronauts can transfer between Earth and the moon, and where resources can be shared among countries. It's all about making sure we don't leave anyone behind and that we pool resources to make this mission as sustainable and successful as possible. There's also talk of creating lunar research stations and habitats in partnership with other nations. Countries like Russia, China, and even India have ambitious plans for their own lunar missions. China, for instance, is already laying out plans for a lunar research station called the International Lunar Research Station, which it hopes to build in partnership with Russia and other countries. This is all part of a larger vision for a multinational moon base, where each country brings its own expertise to the table, whether it's advanced robotics, life support systems, or lunar mining techniques. Now, while government agencies are making big moves to get us to the moon, there's another crucial player in the mix: private companies. Over the past decade, private companies have been transforming the space industry, and the moon is no exception. Companies like SpaceX, Blue Origin, and Lockheed Martin are no longer just building rockets. They're also creating the infrastructure and technologies needed to establish a permanent lunar base. Take SpaceX, for example. The company is developing its Starship rocket, which is designed to carry large payloads to the moon, and eventually Mars. Starship is designed to be reusable, which means lower launch costs, and SpaceX is already in talks with NASA to use Starship for the Artemis program. The idea is that Starship could land on the lunar surface, bring astronauts, equipment, and even supplies, and then return to Earth. SpaceX has already made huge advancements in reusable rocket technology, and that could make a huge difference in the cost-effectiveness of lunar missions. Then there's Blue Origin, founded by Jeff Bezos. Blue Origin's plans for the moon involve both orbital and lunar landers. They're working on a lander called Blue Moon, which could carry cargo and astronauts to the lunar surface. Bezos has spoken about his long-term vision of humans living and working in space, and he sees the moon as the first step in that process. Blue Origin is also heavily involved in developing technologies for in-situ resource utilization, ISRU, on the moon, which, as we've mentioned before, could allow astronauts to use the moon's resources like water ice and regolith to survive and build infrastructure without constantly relying on supplies from Earth. Lockheed Martin is another key player. They're developing technologies for lunar habitats and surface mobility systems. Lockheed is working on designs for a lunar habitat that could house astronauts for extended stays, along with exploration rovers that will help scientists and astronauts gather data and resources from the lunar surface. One of the exciting things about private companies like Lockheed is that they can work faster and more flexibly than government agencies, allowing for more innovation and quicker prototyping. These private companies are also looking into space tourism, mining the moon for resources like helium-3, which is a potential fuel for fusion reactors, and creating commercial infrastructure like lunar mining operations. If the moon becomes a hub for space activity, there will be commercial opportunities everywhere, from building lunar hotels to setting up supply chains for businesses operating on the moon. And that could mean the moon isn't just a place for government missions, it could be a vibrant new frontier for industry. The collaboration between public and private sectors is a huge part of what will make a lunar base possible. Governments have the funding, the long-term vision, and the capability to manage international collaborations and large-scale infrastructure projects. But private companies bring innovation, speed, and the ability to scale projects quickly. Together, they'll drive the progress needed to establish a sustainable presence on the moon. So far, we've talked a lot about the challenges of setting up a lunar base, the tech we'll need, and how different countries and private companies are coming together to make it happen. But here's the big question. Once we've got a foothold on the moon, what comes next? And why does it matter for the future of human space exploration? The answer is simple. The moon could serve as a launch pad for the next big leap, Mars and beyond. The moon is often called Earth's eighth continent, and for a good reason. It's the perfect place to test out the technologies and strategies that will be essential for exploring other planets. Mars might be our ultimate destination, but the moon offers a unique opportunity to practice, fail, and refine our approach before we go all in on something as far away and as complex as Mars. It's not just about the moon itself, it's about using the moon as a stepping stone for the deeper space exploration that will follow, without needing to ship everything from Earth. But the moon isn't just useful for Mars, it's a gateway to exploring the outer solar system. Imagine a mission to Jupiter's moons or Saturn's rings, missions that are far too costly and complex to launch from Earth alone. A moon base would allow us to test the long-term effects of deep space travel, radiation shielding, and life support systems before sending humans to more distant worlds. Essentially, it's the perfect place to test the limits of human space exploration and technology in a more accessible environment. And speaking of testing technology, one of the things we could do on the moon is mine resources that would be vital for future space missions. We're talking about things like helium-3, which is thought to be abundant on the moon and could be used in nuclear fusion reactors, providing an almost limitless source of energy. The moon also has a variety of minerals and materials that could be used to build infrastructure, create fuel, or even support life. Mining on the moon could create an entirely new industry, one that could support humanity's expansion into space. But the moon also holds another key advantage when it comes to Mars missions, and that's proximity. Mars is on average about 225 million kilometers away from Earth, and when you factor in the time it takes to get there, roughly 6 to 9 months, launching a mission is a huge commitment. But by setting up a base on the moon, we could create a pit stop of sorts for missions to Mars. Spacecraft could refuel in lunar orbit, pick up supplies and be restocked before they make the long journey to Mars. In a way, the moon could become the hub of an interplanetary transportation network, connecting Earth, the moon and Mars in a way that makes deep space travel much more feasible. We also can't forget about the fact that the moon provides a unique opportunity for scientific research. The moon's surface is untouched by Earth's weather or geological activity, which means it's an ideal place to study the solar system's history. By building observatories on the moon, we could get a clearer picture of the universe, beyond the interference caused by Earth's atmosphere. Some scientists have even proposed building radio telescopes on the far side of the moon, which would allow us to observe cosmic phenomena without any interference from Earth's radio signals. This kind of research could help us understand more about the origins of the solar system, and even the origins of life itself. Then there's the idea of sending humans to the outer solar system and beyond. While Mars is often seen as the next logical destination, some visionaries are already looking even further: Jupiter's moons, Saturn's moons, and even the Kuiper Belt. These distant places could harbor resources, energy sources, and maybe even signs of life, but getting there will be a massive challenge. That's why having a lunar base as a stepping stone will be critical. It's one of the few places in the solar system where we can refine the technology, test deep space systems, and prepare astronauts for what lies ahead. Mars is just one piece of the puzzle. With the infrastructure we build on the moon, we can work toward human expansion throughout the entire solar system. Think of the moon as a launchpad for the stars, a stepping stone that allows us to reach higher, go further, and explore the unknown. And when we've perfected the technologies, established the networks, and learned how to live in space, we'll be ready to make humanity a truly interplanetary species. As we wrap up this journey through the process of building a lunar base, there's one last piece we should consider. What happens after we've established that permanent human presence on the moon? What will the legacy of a moon base be, not just for space exploration but for humanity as a whole? The truth is, the impacts of establishing a base on the moon will extend far beyond space. It could change everything, from the way we live on Earth to how we think about our place in the universe. Let's start with the practical side. A permanent presence on the moon will require innovations that could have ripple effects on life here on Earth. The technologies we develop to survive on the moon, to create habitats, grow food and extract resources, could have applications in solving some of Earth's most pressing problems. For example, we're already developing closed-loop life support systems to recycle water, air, and waste on the moon. These systems are designed to work in an environment where resources are scarce, and every drop of water counts. But think about it, these systems could be adapted for Earth's dry regions, places where water scarcity is a growing issue. Imagine using moon-based technology to help irrigate crops in drought-stricken areas or build more sustainable water purification systems. The energy solutions we come up with on the moon could also transform life on Earth. Solar power is one of the most promising energy sources for the moon, especially given that sunlight is consistent in certain parts of the lunar surface. We could develop more efficient solar panels, better storage systems, and power distribution networks that could be used to provide clean energy back on Earth. And with the moon being such a valuable resource for energy and materials, it could also lead to breakthroughs in energy production that go beyond the fossil fuels we rely on today. If we can harness the moon's resources for energy and materials, it might just be the key to solving our energy crisis here on Earth. But it's not just about solving practical problems. The legacy of a moon base could go deeper. It could inspire future generations in ways we can't even predict yet. Think back to the Apollo missions. They didn't just put a man on the moon, they inspired millions of people around the world to dream bigger. The idea that humans could actually leave Earth and set foot on another world captured imaginations and sparked a new era of technological advancement and curiosity. A permanent base on the moon could do the same, but on a much larger scale. Kids growing up in the next couple of decades will see the moon not as some faraway place but as a real, tangible destination where humans live and work. The idea of space will shift from something abstract, something for the future, to something immediate and achievable. Who knows how many future scientists, engineers, doctors, or explorers will be inspired by seeing humanity not just visit the moon, but actually build a community there. The moon could ignite a new space race, not between countries but between ideas, pushing the boundaries of what we can achieve and how far we can go. The moon base could also lead to an era of unprecedented global cooperation. Unlike the space race of the 20th century, when countries competed to claim space dominance, the moon base will likely be a shared, international endeavor. Countries will have to collaborate, pooling their expertise, resources, and manpower to make it work. It'll require us to rethink how we approach international relations, governance, and collaboration. With tensions often running high here on Earth, the success of a global lunar mission could be a beacon of hope, proving that we can come together as a species to achieve something bigger than ourselves. It's not just about space, it's about our collective future. And of course, there's the cultural and philosophical impact. When we land on the moon, it won't just be a scientific achievement, it will be a reminder that humanity is capable of great things. For centuries, we've looked up at the stars and wondered if we're alone in the universe. A moon base won't answer that question, but it will answer another one. Can humanity overcome its differences and its limitations? Can we reach for the stars and build a future beyond Earth? The answer will be a resounding yes. The moon is just the beginning, and as we look to the stars, we'll carry with us the knowledge that we are capable of achieving the impossible. Now let's think about the moon base in terms of sustainability. One of the key aspects of building a base on the moon will be how we manage our resources. The moon doesn't have the resources we take for granted on Earth. It doesn't have an atmosphere, oceans, or forests to provide us with what we need. So, everything will have to be recycled, reused, and produced locally. That's the concept of sustainability, and it's something we're already learning to implement in space. But if we can make sustainability work on the moon, it could teach us how to live more sustainably here on Earth. The challenges we face on the moon, how to live with limited resources, how to recycle everything, how to reduce our impact on the environment, could help us tackle the very same issues back home. There's also the question of who gets to live on the moon. A permanent base could open up new opportunities for people, especially as space tourism becomes more common and affordable. Imagine a future where people can live and work on the moon, or take short trips there for research, leisure, or business. Just as the internet has changed the way we connect, a human presence on the moon could change the way we think about space as a place to visit, to learn from, and to call home. It could also lead to the development of new industries, space tourism, moon mining, lunar manufacturing, that we haven't even fully envisioned yet. The legacy of a moon base is one that goes beyond technology or exploration. It's about what it means to be human, to push the boundaries of what's possible, and to look toward the future with hope and determination. As we continue to build on the moon, we're not just expanding our presence in space, we're expanding our vision of who we are and what we can achieve. The moon is not the end of the road, it's just the beginning of something much bigger.